In this question, we're given a series inside a parallel circuit, and they want to know what is the current at this position. So the first thing you should do is redraw this circuit so it's just a series. So what I did, you had to find the total resistance of the parallel. So 1 over 2000 ohms plus 1 over 6000 ohms would give you a decimal, but then you have to invert that number. So the total of this circuit was 1500 ohms. And then the total resistance in the circuit, the series circuit, would be 4000. And then once you know the resistance and the voltage of the battery, you could find the current at this point because the flow is still the same. There's no split or junction at this point. So you would do 12 divided by 4000 to get 0.003. That would be the same current over here. And since all the choices are in milliamps, you can multiply 0.003 by 1000 to get 3 milliamps. Next question asks, how do the currents 1, 2, and 3 compare? Well, first we found that the current at resistor 1 was 0.003, and then to find the rest of the resistances, we would have to find the voltage at this point so we could know what the difference is in the circuit, the voltage drop. So to find the voltage at resistor 1, you had to do the current times its resistance, and that was 7.5. And since we know that the total voltage from the battery is 12, the leftover voltage, or whatever, the voltage drop, would have to be 12 minus 7.5. So 4.5 is the remaining voltage inside the circuit, which would be the same for both resistor 2 and 3 because they're in parallel. And once you find their voltage drops, you could plug it into the equation V equals IR to find the current of each of them. So the current would be the resistance divided by the voltage. So for resistor 2, I got 444.4 ohms, and for resistor 3, I got 7.5 times 10 to the negative 4 ohms. And then, just by looking at the numbers, you could say that resistor 2 is greater than resistor 1, which is greater than the current of resistor 2 is greater than 1, and 1 is greater than 3. You could also compare them according to its resistance, because the greater the resistance, there's like less current. So this would have the least, and then the resistance of resistor 1 is greater, so there's less current. And then resistance 2 has the least resistance, so it has the most current. Yeah. In which circuit is the current furnished by the battery the greatest? So which circuit has the greatest current? So in circuit A, the total current, first of all, the total resistance of the parallel circuit would be 1, because you would take the inverse of the resistance here and here, and the inverse of that sum to get 1, and the total resistance of the series here is 4 when you add these two resistors, and the total resistance of this series is just 2, and this series is 6. Since they all have identical wires, the one with the least resistance has the greatest current. So circuit A. Next question. 23. In which circuit is the equivalent resistance connected to the battery the greatest? For this question, you just have to look at each diagram, and whichever value has the greatest resistance. So the series circuit D with 6 ohms has the greatest resistance. Which circuit dissipates the least power? So we know that the power equals the current times the voltage. We don't know, well, we can assume the voltage is the same because of the statement. So wherever there's the greater resistance in these circuits, there's the least current. So circuit D has the greatest resistance. So there's the least current in this circuit. So there would be the least amount of power at circuit D. There are 4 identical light bulbs, and in question 37 we want to rank the current through each bulb. So from the battery source, N is on the main branch, so this is the one with the most current, so we could cross out A and B, which state that L is greater. So then from here the current splits. So in this circuit here, L and M are in series, so they would have the same current, and K would have twice the amount of current than L and M, since L and M would have twice the resistance than K. So L and M have a lesser value of current than K, because the greater the resistance, the less the current. So N would be greatest with K greater than L equaling M. In question 38, in order of decreasing brightness, the bulbs are, when we're talking about brightness, think power. So the current times the voltage is equivalent to the power. So according to the previous question, we could use that wherever the greater current value is where you'll have the most power. So N, then K, and then L and M, they equal because they would have the same current value.